Hello, welcome back to my shop. Today we have another antique. This this is quite old actually. It's somewhere in the 60s. Not really sure when because I can find virtually no information about this on the web at all. This is a Link Type 2051A frequency meter. It is serial number 657712. Yeah, no, 65772. It came out of one of my transmitter sites. It's quite old, as you can see, and this thing's been modified. We'll get into that in a minute. In the old days, people didn't have frequency meters like we have now that read out nicely in digits for you. At least not anything that would be accurate down to cycles per second, or as they called them in those days, now we call them hertz. So they had to do it in a different way. And the way they did it was with these guys, with a frequency meter. Now this one is a frequency meter and a deviation meter. This meter doesn't do anything with frequency. It's interesting. You'll find out. Originally, this was a 2-channel device. It had 2 individual channels that you could put in with crystals, and it was meant for VHF transmitters. One of the frequencies that we had at the radio station was 170.150, which this crystal is here for. Now, when they were doing the tests on their equipment back in the old days, and they wanted to certify that they were right, there were rules, and there still are rules as to what you had to use in order to get them, down to be accurate to within a certain number of hertz. And right now I'm afraid I can't remember what that is. But anyway, and there were very limited ways to do it, and the FCC that said that you had to have a certain your test equipment had to be a certain amount of accurate. So what they did on this one is they took out the 2 channels, they replaced it with a single channel, and another thing I'll show you, and put in a crystal with a heater in it. And basically, this crystal, it comes on a tube socket, and we'll open this up just to show you what's in here. It's got 3 little screws around the outsides. These have not been used in a long time. And basically, you've got little active circuit, or a little circuit in there, where this is your tuning, there's your crystal, and this is your heater. This is your heating element. And the crystal is an overtone crystal. I don't know what it is. I don't want to pull it out of there, but it's the thing says 8 to 12 megacycles. So I don't know what the overtones are on this crystal, but this would be calibrated exactly to the frequency that you want after a certain amount of heating up, and then that would be okay. You could turn it in and say that you had calibrated your transmitter and that it was accurate. As this thing sat by itself, it did not meet specs. This is the Hunt Corporation from Carlisle, Pennsylvania. Oh, there's a frequency. It's 5.31718 is the basic frequency. And the heater heats to 32 degrees C, runs on 6.3 volts. Anyway, so basically it is just in a tube socket like that. So what you did with these guys is you took them, you hooked up an antenna to it. I still have the antenna, the original antenna that came with it. It's over here. Just little antenna plugged in here. You set your radio next to it and keyed it up. Got a certain amount of level for RF, and then you could check them. Well, I don't happen to have a radio around here that'll do that frequency right now, so we're going to have to use the signal generator. So that'll be fine. I'll use the my Fluke 6060 AAN as the signal generator. However, we got another problem. This thing runs on batteries, lots of them, and I have some of them, but I don't have others. So anyway, another thing they did is they replaced down here. There was a switch here for channel 1, channel 2. There was nothing here to begin with. They drilled a hole and put in a connector, one of those old mic connectors, for a 6-volt heater. So that's been changed also. The rest of it is the same. So the way you did this is you put your frequency in for your transmitter, and you checked your RF input. You'd go to deviation, and you'd slide this over to the side, and you would listen through headphones down here, high Z headphones. You'd listen to the headphones and make sure that your frequency that you heard, which was a beat frequency against the main frequency, so that you got a whoa, 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 or whatever. We'll hear that in a little bit. And that was it. That's how you did it. And then you could check your deviation on the meter here by this chart. For instance, if you wanted a 5 kilocycles deviation and a solid steady sine wave, you look it up on the chart, you'd go up here, and it crosses right at 30. So 5 kilohertz deviation should be 30 on the meter in the 15 kilocycle position. Over here, there's two positions. There's 15 kilocycles and 5 kilocycles. This chart is for the 15 kilocycle position. So that's how you did it. We're going to go through it and see how it's done. So first of all, I got to get this thing out of here. Like I said, it was heck finding any information on this thing at all. As you can see, it's pretty well shielded. It's in a metal box inside of a wooden box. Very nice wooden box. Leather handle. A little rough. And nice snaps in the front. Yeah, these weren't cheap, let me tell you. All right, let's put this down here. And we'll get this here. All right. So you can see what we got here is a bunch of tubes. How did you do? Wow. Amazing. All right. We got a bunch of tubes. And these are all 1L4s. And let's take a look at the schematic real quick, and I'll show you what it looks like. Here it is. Not locked. So let's open it up. All right. So this original schematic, which is all I could find, and thank goodness I found this on a board someplace. This is not exactly perfect, but it's real close to this one, but this one has been heavily modified. So what we have here is it comes in right there. Okay. I gotta clear. Why do I have to do? Oh well. Anyway, this is your antenna right here where it comes in. Pull this over to the side a little bit. Here's your antenna, and it comes in through there. It comes in through a capacitor, this C10. Now C10 is really kind of interesting. Let's get this out of the way for a minute. This right here is C10. There's a little plug, just like a little banana plug thing that goes into the front of here. This is some sort of plastic around the outside. And then there's a metal collar that goes around here at a specific length from where this plug goes in. And that is your capacitance. That's it, right there. Pretty heavy-duty, non-arcing capacitance, that's for sure. That comes into here, and that is right here into this coil, L8, which is this guy right here that comes down, and another coil that goes to ground, which is this one here. All right. No, not to ground. This one is L4 right there. This is L8, that's L4. All right, so basically comes in, there's a diode here that shows up right there. There's your diode. Little 1N34 going to ground. And it comes into this oscillator right here. This oscillator is frequency controlled by these crystals right here and here. This has been removed. Most of it has been removed, and that crystal in that heating can has replaced Y1. So, and the switch is gone. So it's just one frequency right here. All right, so this switch also is gone. Only L1 coil is in there, and that comes through and goes into these stages over here. Now, if you look at this thing, what you've got is, this is over here. Let's shrink this down a little bit. You'll still probably be able to see it, I hope. All right. Get it up out of the way. All right. This tube is your, right here, your first tube. This is your second tube. This is your third tube, and this is your fourth tube. These are amplifiers and discriminators and detector. And basically, it's just straight. It detects it and just amplifies the frequency that it's detecting, and comes and mixes it with the frequency from this crystal. And you come out with a frequency here that's divided down. Now, I don't really have a book on this thing. It's all I could find was this. And it's all controlled by these switches down here. Now, if you look, you've got a 90-volt battery, which is here. These guys. A 1.5-volt battery, BT2, which goes up to one side. Let's see, BT2, hard to follow, goes up to CR3, and they're back here on the back. And BT3, which is down right here. This is BT3, this is BT2. BT3 is the other direction voltage and goes up to here. So you've got a positive voltage on this one, a negative voltage on this one. And then the discriminator between these two, CR4 and CR3, are tuned by C25, and that comes down and gives you a voltage at position B on this switch here. Gets you back down again so you can see what I'm doing. Okay, so comes down here to this switch B, which is your RF deviation A and B batteries. All right, so you've got this is 3 or 2. Yeah, this is 2. This is 3. Then you got another battery, which is right here, which actually is 2 D cells for 1.5 volts, which are the filament voltage for all the tubes, and then you've got your 100 or 90 volts. Now I don't have a 90 volt battery, so I'm going to have to use a little thing I built here. But that's all that's in there. Well, if you look at this, you'll notice that you've got 5 tubes. 1, 2, 3, 4, and 5. Right there. Well, that is another 1L4. I haven't really checked out to see how it's made, but if we turn the thing over and we look real close down the bottom here, it's sitting on a piece of metal that's been tacked into this thing, screwed down with screws, and modern style capacitors put into it, these Sprague orangies. This is an audio amplifier that somebody put in so that you didn't have to use those awful high Z headphones in here. So that's been modified. The front's been modified for a single frequency, and it's got a heated crystal. So, like I said, pretty well modified. Anyway, so what we're going to do is we're going to hook it up. What I got is this. It's a little thing that I built a while ago. Basically, it just takes my variable isolation transformer in, and it's got a bridge rectifier and a capacitor to smooth it out some, and and a little voltage and current thingy here, so I can get up to about 300 volts without buying a high voltage transformer. It is not great, but it works. So I'm going to turn it on, and we can see here it's 90 volts. Okay? And my actual power supply is set at about 65 volts. All right, so we'll plug this in here, That'll give me 90 volts into the device. Righty, and let's see where we got to. We're going to find the cable. What did I do with it? Connector going right into the front of here. This thing is not turned on. By the way, this doesn't do anything. There's no power supplied to it until you hit this switch down here. So it can work on batteries for literally forever. All right, so now we have the output of the generator going directly into it. I've got this on RF input, and there we go. So we've got RF. If I go to amplitude, see it drop? Okay, so I'm putting, what am I putting into this thing? 560 millivolts. Well, just for fun, let's take it down to 500. Nope. Okay, there we go, 500 millivolts. So we got 500 millivolts going in, got our 90 volts going in, and in order to be able to hear this, or to test the frequency on this thing, I've got this conglomeration of junk going from BNC to dual RCA to quarter inch, and that goes into there. Okay, right into the phone's input, which is now amplified. I think this amplifier is kind of dirty. We'll find that out. And then that goes over to my little amplifier on the bench here. And my frequency is set for 170, 150. What you do is you put it on deviation, which deviation is off right now, and you hit this little button. Doesn't take very long for the tubes to warm up, and that's what you get. You get a tone. All right, so this thing is off frequency a little bit. I've tested my Fluke, and it's real close. So what we'll do is we will start lowering the frequency in steps of 10 hertz. Okay? So you listen to the tone that we're getting out of this. I'll lower the frequency. There we go. We are down. Okay, we are down at 170.149.650. So we're 170.149.650. Hear that? Wom, 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 wom. Okay, let's take it up 10 or 100 hertz, and you can hear the change. I'm going to go from 6.5 to 7.5. That's about 100 hertz. So let's go to 8.5. 200. Okay, so there we are back at 170.150. And there's our frequency. So the way you did them is you listened to it, you counted in your head about how many cycles per second, and you try to get it down as close as you possibly could to the frequency that you needed by adjusting your radio or your transmitter. So that's how you did frequency. And you could get really, really close with these things. I mean, we got down, what did we do? 650. Listen again. That's about as close as I could get. That's about 5-6 hertz off, maybe 7. Anyway, because even this generator doesn't go down to in the single digits. So 655, maybe. I don't know, but it's that would be close enough. All right, so then what you did is you took your headphones out. You turned on your deviation, your FM deviation. I'm going to go with 5 kilohertz deviation, and you hit your switch, and you read your meter in the front. Well, I got 5 kilohertz deviation going into it at 171.5, and I've got showing 30 on the meter. Just to show you, let's take it up to 10 kilohertz deviation, and now I'm reading approximately 60 on the meter, 65, somewhere around there. So I know that if I go down here, back down to 5, it's on 30. I get the lid off of the box, and I look it up. I'm at 5 kilohertz right there. Follow that line up, and it should read between 20 and 40, dead between 20 and 40 on 30. We went to 10 kilohertz deviation. It should be right on 60, right there. 5 goes up to 30. 10 goes up to 60. So, it's accurate. Frequency's off. Oh, let's see. Can't do this in my head, or at least don't want to. So we got 171.50 minus 170.149.655 is what we thought. Okay. 345 hertz, this thing is off. Or if I didn't know that the fluke was accurate, the fluke would be off 645 hertz. So that's pretty close. And I don't even have the heater on because I don't have a 6 volt. I don't have a thingy connect to there. it's not, for this purpose, not that necessary. I don't know what the RF out does because that's not actually in the manual. The manual shows one RF connector, and it's just an RF sample, and it's right here. That is not J1. This thing on the front is not J1. It says RF output. I guess you might be able to read. There might be a sample coming out of there, but I don't have anything good enough to read it. And this little knob on the front, that used to be the balance knob. It doesn't do anything anymore. It used to be for the crystals. So, it doesn't do anything. Anyhow, so, in the old days, that's how they did frequency meter and deviation meter with tubes and no digits. I think it's kind of interesting, really, when you think about it, because they didn't, you used what you had or what you could come up with, and to get as accurate as you could. And I'll tell you what, if this thing was calibrated correctly and set up right, this would be more accurate than my frequency counter, my digital frequency counter, because I could listen to it and get it down to within cycles per second. I mean, all the way down to a half a cycle per second by listening to it through a set of headphones. That's pretty impressive when you think about it. Also has negative deviation, which I don't think that's right. You reverse the deviation polarity. I don't think that's right. I think that's wrong. But, I don't have any kind of a manual. I had to fix this a little bit before we did this, and because I didn't have a manual, I didn't show you guys, but it had a bad diode, horrible battery contacts, just shot to heck, and I had to trace the whole thing out because, like I said, it's really been modified a lot. As you can see, here's where it comes in with the new oscillator crystal into this tube socket, which wasn't there. And I can't even find a picture of this thing online. I mean, nothing even close to it. So, anyhow, there it is. A link. Type 2051A frequency meter and how old frequency meters worked. They were pretty cool. And if they're calibrated, extraordinarily accurate. All right. Hey, thank you for watching, and hope you enjoyed it. Give it a thumbs up, please. And don't forget to subscribe and hit that button. And oh, yeah. And I wanted to mention, too, I started a website. I've got aervblog.com. I haven't got much up there right now, but it's going to be more or less just stuff that I did, and little pictures of things that weren't really worth putting a video out on, or mistakes that I made that you can watch on, and stuff like that. So if you go to aervblog.com and take a look, and let me know on the articles, you can comment and let me know what you think. So, hey, thanks for watching. Till next time.